out this question, minimum depth of a binary tree. It is Leetcode today's daily challenge. So what we have is we are given a binary tree and we have to find its minimum depth. What is minimum depth? Minimum depth is the number of nodes along the shortest path from the root node down to the nearest leaf node. So we are given a binary tree and we have to find the number of nodes along the shortest path from the root node to its nearest leaf node. Let's say if we take this example, 3 is my root, and if I count the leaf nodes, then 9, 15 and 7. These three are my leaf nodes. So I have to count the number of nodes on the shortest path. If I traverse from 9, I get 2 nodes over here. From 3 to 9 I have 2 nodes. If I check 15, there are 1, 2, 3 nodes. And similarly for 7 also there are 3 nodes. So out of these 3 paths, 2 is the one which is having minimum value, so it is the minimum depth of my tree, and we can see that the answer here is also 2. Okay, so let me explain you with one more example. Let me just draw a tree. Let's say this is my tree. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is my tree. This is my root node, and if we check the leaf node, then we can see 10, 8 and 9 and also 5. These are my leaf node. If I measure the path from the root to all these leaf node, from 1, if I go to 4, I will get, I go to 10, I get 4 nodes. If I go to 5, I get 3 nodes. If I go to 8, there I get 5 nodes. And if I go to 9, I get again 4 nodes. So out of these 4, if I check, then the 3 is what is the minimum value. So this will be my minimum depth for this tree. Rather than just counting the nodes along the path, we can see that if we find the level of each node, let's say this is level 1, this is level 2, this is level 3. Level is the number, like height wise level, which we encounter when we traverse the tree, and this is level number 5. I can see that the number of nodes encountered for each leaf node along its path from the root to that particular node is equal to its level. What I mean is, if I see for 5, I can see that, let me take other color. Okay, I see that the path has 3 nodes from root to 5, and the level is also 3. And if I check for 10, there are 4 nodes along its path and its level is also 4. Similarly, if I check for 8, the level is 5 and the number of nodes along the path is also 5. So basically, number of nodes along its path is equal to each node's level. So instead of counting the nodes, what we can do is we count the level, and whatever leaf node is at the minimum level, that means minimum is the closer to root, that will give us the minimum depth of the tree. So how we can proceed in this question is, we'll simply check first. Let me just take it. Okay, if root does not exist, that means if it is a blank tree, null tree, then there is no leaf node or root node, so I'll simply return 0. Otherwise, I'll check if the root have any children. If the root has any children, that means I need to check their depth of the leaf node. If there is no children, then it means the root is the leaf node. So the path from root to leaf will only contain one node, that is root. So I'll simply return 1. Otherwise, what I'll do is I call on the left and I call on the right. Okay. If left is 0, that means there is no node in the left tree. So there is no leaf node, there is no path. So I return 1 plus r. Whatever I get from left side, I return 1 plus r. Otherwise, if left is not 0, And if right is 0, that means there is no leaf node in the right side of the tree. So I will have the leaf node only in left side of the tree if left side is there. So I will return 1 plus L. Otherwise, if neither of these two is 0, what I'll do is I'll take minimum of left and right, and I'll return 1 plus that minimum value. Let me just elaborate how this code will work and how algorithm is working. Just give me a minute. Okay. So I'll take a few examples. Let's say this is example 1. Let's say this is a leaf node, and this is example number 3. Okay. So like if I take this tree, there is only one node, leaf is root. So in this question there is no left and there is no right. So in this case what we will do is we will simply return 1 because root have no children, we return 1. Otherwise if we see here in this case we have 1 and 2. Root is not null and root have children. So I will call on the left. There is no node on the left. So on left I will get value equal to 0. I will call on right. Since 2 is not null and then so I will call on children, but there are no children for 2. So since L and R both are 0, so I will return 1 plus 0, that is 1 from here. For 1, I will see that the left side gave me 0. So in this, I will return 1 plus R. And I can see that from the left, I got 1. So the minimum depth in this case will be 2. Like this is a leaf node. Let me just erase the extra part. Okay. So I can see that this is my root and this is a leaf node. So if I traverse the path from the root to leaf, I get only 2 nodes. So the answer is 2. Now if I come to this tree, just a minute. Okay. If I come to this tree, 1 is my root. Root is not null, so this condition is not satisfied. I'll check if the left and right children doesn't exist. So they both exist, this condition is also not satisfied. I'll come here, I'll call on the left, that is 2. For 2, when I call on its children, both are null, so it will simply return me 1. Sorry, it will simply return me 0. For 2, left and right gave it 0. So left is 0, I return 1 plus R. Since R is also 0, so I return 1 from here. So L value becomes 1. Now I call on the right. For 3, I can see that there are no children. So I'll get 0 from them. Since for 3, L is 0, so I'll return 1 plus R. R is also 0, so it will also return 0 plus 1, that is 1. So L is 1 and R is 1. I see that if L is 0, no, L is not 0. This condition is not satisfied. I check if R is 0, no, R is also not 0, so this condition is not satisfied. So what I'll do is I'll take minimum of L and R. So minimum of 1 comma 1 will be 1 only, and I'll add 1 to it, so it will be 2. So the minimum depth of the tree, that means the minimum number of nodes along the shortest path from the root to the leaf node is 2. So the minimum depth for this particular tree is 2. So that's how we'll do this question. Let me just erase it so you guys can see the code once. I hope it is clear, and let me know if you have any doubts or any confusion.